It's a great pleasure to share my passion for AI in manufacturing with all of you. AI spent the first 6 decades of its history flying below the radar, and now it has suddenly exploded into public consciousness. We need stop-action photography to resolve the blur of events. Manufacturing is a data and knowledge-driven process, and even though we've been at it for thousands of years, it's all about manipulating molecules, and we still can't do atomically precise manufacturing at scale. In spite of that, the historical trends in materials and manufacturing are clear. Increasing precision, decreasing cost, increasing flexibility, increasing speed, in fact, accelerating speed, and complexity is now free. The MIT Press published this seminal work in artificial intelligence applications in manufacturing 14 years ago. And thanks to advances in hardware, in algorithms, in cheap sensors, and in access to data, things have really changed. So what can AI now contribute to manufacturing? Faster actions and decisions, product, service, and material innovations, improved efficiency, higher accuracy, lower cost, and increasing scale. And it's not just about improving things on the manufacturing floor, but improving things throughout the manufacturing enterprise, from design, diagnosis, customer service, sales and configuration, and quality control. General Electric has been using AI in its manufacturing process for 3 decades. They're using big data to make smarter turbines. They've been using AI to diagnose problems in their train engines for decades. Business Wire just published a report a few weeks ago on a collaboration between robot manufacturer Fanuc, Rockwell Automation, Cisco, and Preferred Networks, an AI company, and they're all about creating an advanced analytics platform for improving overall equipment efficiency on the manufacturing floor. Yale University has published a series of articles on using machine learning to provide integrated optimization of semiconductor manufacturing. If you're interested and you're in that area, check it out. General Electric has also provided a software fabric to go over traditional manufacturing floors to provide increases in prediction, responsiveness, and connectivity, to take a standard manufacturing floor of old-style equipment and turn it into a software configurable manufacturing engine. IBM has graduated Watson from playing Jeopardy games and working in medicine to Watson Explorer for manufacturing, a single portal for integrating all of the information from the manufacturing enterprise. And Amit Saha wrote a beautiful blog on the IBM Watson blog just a few weeks ago on how content analytics, text analytics, and NLP, natural language processing, has helped auto manufacturers identify potential product liability just by looking at Twitter feeds and customer feedback. So there's been an increasing pace of AI investment and acquisition. From 2011 through 2015, over $3 billion in VC funds were invested in cognitive technology, and during the same period, over 100 AI-related companies either merged or were acquired by the typical suspects: Alphabet, IBM, Facebook, Amazon, Apple. Many of you have heard about the win of Alphabet's AlphaGo system over the world champion in Go, this fellow, Lee Sedol, Korean world champion in Go. In contrast, chess has 35 moves per average turn. Go, 250 moves per average turn. Go is epically complex. This achievement, where AlphaGo won against the world champion in Go 4 games to 1, is a watershed moment in AI. It has created what's called AlphaGo shock, which led the Korean government to promise $3 billion for an AI R&D program aimed at what? Manufacturing. So the underlying technology behind that AlphaGo player was a pioneering technology that combined convolutional neural networks, you can think of that as a fancy word for pattern recognition agent, with reinforcement learning that reinforces that agent for a high score in an arbitrary Atari 2600 game. These systems were developed by DeepMind Technologies in the UK, demonstrated for the first time in 2013. The system started from zero knowledge of any of these Atari games, and they outperformed all previous approaches, machine learning approaches, and did amazingly well. They discovered strategies on their own. Take a look at this. This is Demis Hassabis from DeepMind Technologies, and you can see this system missing balls. But after 120 minutes of training, this machine learning system begins playing at a kind of mediocre human level. You can see the score is not very exciting. But then, after 240 minutes of training, watch what happens. The system tunnels up the left-hand side of the screen and plays from the back court where the game has no defenses. That is a real breakthrough in AI. And people often describe AI as a game-changing technology. But it's actually much more than that. AI is disrupting the entire field that we are operating on. Just a month after that seminal demo, then Google acquired DeepMind Technologies for more than $500 million. I know the guys at DeepMind Technology, they're very happy at Alphabet now. So what is AI? People often want definitions. It's pattern recognition techniques to solve practical business and technical problems, software agents that can utilize resources efficiently, a vision of superhuman intelligence that hasn't happened yet, but is often hijacked by science fiction movies and the media to sell tickets. And it's computer science accelerating other technologies that you'll be hearing about at this conference, 3D printing and robotics, nanotechnology. So this is a good news, bad news story. When I go to a fancy cocktail party, I was recently at the Plaza Hotel in New York, people ask me what I do. I tell them I'm in AI research and education. The woman to the left of me said, "Oh, that's so great. Now we get to combine our genomics data and our wearables data, and we can manage our healthcare like the CEOs of our own healthcare using the power of IBM Watson." But the guy to the right of me said, "Oh, you're in AI? I know what you're up to. You're building this." Now, the truth is that most of the work that goes on in AI and robotics is not going to result in these sort of science fiction scenarios. But if anybody tells you that the long-term consequences of AI will be all good or all bad, they are cherry-picking the data. I welcome you to the adult conversation. AI comes with trade-offs. Yes, faster, cheaper, better problem solving, but also job disruption, human identity change, and risk amplification, and sometimes risk reduction. The AI community is taking risks seriously. I was recently invited to a conference on the future of AI in Puerto Rico, where Elon Musk and Nick Bostrom, who are very concerned about the risks of AI, joined with 50 AI researchers, and we sat around for 3 days and talked about the research agenda needed over the next few decades to keep AI doing beneficial things for us. And a year after that, Elon Musk worked with people from Y Combinator to create a new organization, OpenAI, to pursue advanced AI in the open so that everybody has access, not just big companies. And they're investing $1 billion and some great researchers in that endeavor. They have already put out their first product, the OpenAI Gym, to evaluate different reinforcement learning algorithms. Fortune magazine had a front cover story, "Humans are underrated." Well, what do you think? The human brain evolved under very different circumstances than the ones that we have today. It hasn't had a major upgrade in over 50,000 years. If your laptop or your cell phone hadn't had an upgrade in 5 years, you'd be concerned about that. It has limitations in memory, speed, bandwidth, and bugs in cognition. We're going to have to augment our cognition, both in everyday life and on the factory floor. We're going to use statistical and deep machine learning, task and domain-specific knowledge engineering, marshaling the data, and biologically inspired computing architectures, like deep learning. Deep learning is the champion algorithm in machine learning. It's been winning all the contests. And one of the things it does is hierarchical pattern recognition. And you can see on the screen that you can start with pixels and then go to edges. And then it begins to recognize object parts at the next layer of the hierarchy, and finally objects. And you can add arbitrary numbers of layers, 152 or 300 or 1,000, and get amazing feature discrimination. Here's a company called Sentient.
Vast, unfathomable amounts of data.
130 million invested in them. Volume, please.
And yet, how do we make sense of it
Pick up the volume, please.
How do we use it to solve our problems instead of creating more? We started a conversation with some of the brightest minds in the fields of big data, cloud, and artificial intelligence, and asked that same question. We asked, what would happen if you could get evolved artificial intelligence to pose the right questions? What if you could put those questions to millions of distributed processing cores and get them to work together? You'd get artificial intelligence on a massive scale.
Scale is the issue.
You'd get unprecedented decision-making power distributed closer to the data. You'd get the first massively scaled evolutionary distributed artificial intelligence technology applied to making better decisions.
I think you get the idea. DARPA, the Defense Advanced Research Projects Agency, has a new program called Probabilistic Programming for Advancing Machine Learning. And what that's about is opening up the black box of machine learning algorithms and getting them to play well with others, particularly relevant for the manufacturing floor, where we want to be able to use simulation and optimization and get all these algorithms to play together. AIs have been sponsored by governments and companies all over the world. I did a study of 360 different applications of AI, and these are the patterns that I found in common between them. It's not just better, faster, cheaper. It's different. AI allows us to expand the range of the possible. So AI is here now, not in the form of HAL from the movie 2001, but in the form of practical business and manufacturing problem solving. I'm encouraging you to create an application-oriented AI toolbox. If you're interested, you can download this infographic by Googling Machine Intelligence 2.0 and Bloomberg, and you can download this onto your laptop. It's just lots of different examples of machine learning companies and techniques, all classified into different bins. There's a company called Newtonian that you might want to track. They have a machine learning product called Eureka. A company called Rio Tinto was working on powdered metal steel, and they were having trouble in their quality control. They used Eureka to analyze many different variables involved in their powdered metal manufacturing process, and it turned out that one of the variables that they just threw in there for kicks turned out to be the really important one causing their quality control problems. And here is GE using AI and machine learning to improve their ceramic composites. They're also doing that with plastics. If you're interested in increasing your bench strength in AI and machine learning, if you don't have the bench strength in your own company, you can extend your bench strength by putting out your data in the public and putting up some prize money at Kaggle, and the world's greatest data science teams will compete for the solution to your problem. This is a very successful system. Another way to do it is to try it at home. People often say, well, don't try this at home, folks. I'm encouraging you to download R or RStudio onto your laptops, and if you need to, recruit a high school student to help you and try it at home. Another way to increase your bench strength is to use a company called Experfy that curates a marketplace of qualified data scientists. They came out of the Harvard X Innovation Lab. And they allow you to just put out your problem without revealing your data and then pick a qualified data scientist to work with you. Let's talk about some work implications. The Atlantic magazine had an article on technology potentially erasing millions of jobs. You may recognize this as the birthplace of Hewlett-Packard. I would say that assuming 0 new technology breakthroughs, professional work is ripe for disruption. Consultants tend to say all jobs can be automated except ours, of course. The Oxford Martin School had a study in 2013 of the next 10 to 20 years of the American job market. They concluded that 47% of the most routine jobs in America would be vulnerable to automation over the next few decades. They updated their work over the last few weeks. They put out a new report called Technology at Work 2.0, where they looked at the entire world and they concluded that developing countries have an even bigger problem. They have more people involved in routine work, both in factories and in administrative jobs. Their risk is even higher. That suggests we're going to need to team with AI's strengths. That way we'll get best-in-class performance, at least for some tasks, fewer biases in decision-making, super fast operational velocity. We'll be able to team with a partner that works 7 days a week, 24 hours a day, no vacation or sick leave required, no health care, no whining, but limited empathy, language understanding, and social grace. The winning formula for working with AIs and robots, for that matter, humans plus AIs plus good business process. That's more powerful than AI alone. We're going to be able to combine that power to increase our productivity remarkably. We're going to build very, very smart systems. We're going to reverse engineer the human neocortex, make vast artificial neocortex, and make our factory floor super smart. People often ask us how to think outside the box. My answer, there is no box. Remember that AIs are going to change the balance of power between your big company and small startups. Here's some operational recommendations. To transform manufacturing products and services, to team humans plus AIs plus best-in-class business process, that winning formula. Utilize the power of machine and deep learning. Try all the free tools that are out there. They're surprisingly powerful. Leverage AI platforms in your manufacturing operations, not just in your customer-facing products and services. Outsource and increase your bench strength with Kaggle, Xperfy, and other crowd services, and be proactive about security, ethics, and product liability. It's important to keep a sense of perspective about this. This photograph is from Jupiter's orbit looking at Earth. That's us. That's everyone that you've ever known has lived on this planet. Everyone you've ever read about in human history. If it isn't obvious by now, we are all in this together, and we better act like it. Thank you very much.